Hello, my name is Angelica Coriano. I'm a student at Valencia College in the Electrical Engineering Technology degree. This is my video submission for lab number 10 for CET 2114C for Digital Systems, Professor Ashley Evans. This is going to include one part only, which is one circuit that is being built, and I'm going to begin with it right now. This lab, we were tasked with building this circuit right here, which involves a multiplexer connected to a demultiplexer, and both of the select and data inputs being controlled by a 2-bit counter. This is the way I built the circuit. Let me turn it off. And I'm going to explain how it is wired right now. So this is the circuit right here. I have 3 IC chips. Beginning from the left, I have the 74151 chip, which is the multiplexer chip. In the middle, I have the 74138 chip, which is the demultiplexer chip. And then on the right, I have the 7476 IC chip, which is the JK flip-flop IC chip, which I'm using to create a 2-bit counter. I'm going to start with the far right, which is my JK flip-flop and how I created a 4-bit or a 2-bit or mod 4 counter from it. So I connected the flip-flops asynchronously, meaning that the clock input of the second flip-flop is the output of the first flip-flop. All my J's and my K's for both flip-flops are connected to the VCC, which is the positive rail. So the positive rail here is connected to the 5-volt VCC, and they're linked together. And then the ground is connected to the negative rail, and they're linked together. So all my J's and K's are connected to the 5-volt VCC, and those J's and K's are pins 16, 12, for 1K being 16, 12 being 2K, meaning the K input of the second flip-flop. Pin 9 is the J input of the second flip-flop, and pin 4 is the J input of the first flip-flop. They're all connected to the VCC, which is these little blue wires. The presets and the clears are active low. So for them to work, they need to be, for them to set or clear, they would need to be set to a low. So to avoid that, I've connected them all to high. So the set, preset, and clear for the first flip-flop, which are pins 2 and 3, are connected to the VCC. And then the set and the clear for the second flip-flop, which are pins 7 and 8, are also connected to the VCC. The output of the first flip-flop, which is pin number 15, it's connected with that brown wire, is being linked to the clock input of the second flip-flop, which is pin number 6, which is where you see it's ending right there. And the clock input of this IC chip is this big old red wire, which is going to the logic switch so that there's a smooth transition. Smooth transition for this clock, and we can see how it goes. For this ICC chip, there's obviously a VCC in and ground. The VCC is pin number 5, which is right next to this brown wire. Pin 5, which is connected to the VCC. The ground is pin 13, which is that one, that's the only one going to the ground on this side. And that is how my 2-bit counter is created, with pin 15 being the output of the first flip-flop and pin number 11 being the output of the second flip-flop. So if you were going to go in order and look at it like to count up to 3, A1, A0, it would be A1, A0. In the sense like 0, 1, 1, 0, 1, 1 to count from 1 to 3. Now, on my left-hand side, I have my multiplexer and my demultiplexer, which is in the middle. The way these are connected is a little bit different, obviously, because they needed to be... Oops, sorry, didn't mean to swipe my hand across. I was just trying to make sure the iPad didn't close off. Connected just a little bit differently so that the inputs of the multiplexer, which are coming into the first couple of pins, will translate to the demultiplexer, and you can observe those in the output. So with the multiplexer, the first 4 pins, pins 1, 2, 3, and 4, are I3, I2, I1, and I0 respectively, with pin 1 being I3 and pin 4 being I0, and going that way. They're connected to switches 0 through 3. Switch 0 is going to I0, which is pin 4. Pin 1 is going to I1, which is pin 3. Switch 1 is going to I1, which is pin 3. Switch 2 is going to I2, which is pin 2. And switch 3 is going to I3, which is pin 1. So I have black, black, yellow, white. And then here you can see black, black, yellow, white for pin 4, 3, 2, and 1. And those are the inputs for the 151 multiplexer. The other inputs are actually on the other side, but we're not using them right now. We're just showing 0 through 3. The outputs are pins 5 and 6, with pin 5 being the normal output of the multiplexer, and pin 6 being the inverse output of the multiplexer. Pin 6 is connected to, you can probably see here, it's connected to the 138 chip. It's connected to G2B, which is pin 5. It's one of the enables, but it's one of the enables that is active low. So the only way you can operate this one is if the input going through this enable is a low. If it's a high, it's not going to work. And since it's the inverse of the output, anytime the output is 1, it selects one of the data inputs and the data inputs are 1, that output's going to be 0, and then it'll enable your 138. If you have a 0, your inverse is going to be 1, and that's not going to enable your 138. So that's kind of how that's working there a little bit, so that it works together. Going back to the 151, I have my enable, which is actually a low, connected to the ground, active low, so that it can enable the circuit. My ground for this IC chip is pin number 8. It's connected to the ground. The VCC for this chip is pin number 16, which is this purple wire you see right here. S2 on this chip, which is another select, so I have several selects, is connected to the ground, which you can see right there. It's this blue wire right over here. And it's kind of jumbled, but that is going to pin number 9. And that is connected to the ground. That way the select only goes from 0 to 3. Alright. For select 0 and select 1, which is pin 11 and pin 10 respectively, those two are coming from the mod 4 counter, which is the 2-bit counter, with S0 being taking the input, the input of S0, which is pin number 11, taking its input from the output of the first flip-flop, and then S1, which is pin 10, so to the right of it, is taking its input from the output of the second flip-flop. The outputs are right here. So pins 15, let me double check to make sure. Yep, pins 11 and 15 are the outputs of the flip-flop, with pin 11 being the output of the second flip-flop, and pin 15 being the output of the first flip-flop. Those are connected to several things. So the output of the first flip-flop is connected to the S0 select. The output of the second flip-flop is connected to the S1 select, and S2 select is connected to ground, so that it only counts from 0 to 3. Sorry. Besides being connected to the 151 IC chip, it's also connected to the 138 IC chip as its data inputs. The data inputs are pins 1, 2, and 3, being A, B, and C. Just like the selects, I'm sorry, I'm kind of shaking a little bit. Just like the selects, pin 3 is connected to ground, so it's only counting 0 to 3. Pin 1, which is A, is connected to the first flip-flop, which is pin 15. And pin 2, which is B, is connected to the second flip-flop, which is pin 11 on this IC chip, so that it's counting 0 to 3. I have pin 4 connected to ground, which is one of the enables. That enable is low, activated by low, so it's connected to ground, so it's enabled. The other one is enabled by high, so it's connected to high. And as I had mentioned before, the inverse output is connected to that second low enabled second enable that is active low. And the ground for this chip is pin 8. It's connected to ground here. And the VCC, you can barely see, it's that little blue wire, tiny blue wire right here, is connected to the power, to the VCC in for the chip. The outputs, which are pins 15, 14, 13, and 12, Y0 through Y3 respectively, are connected to LEDs. These are the LEDs. LED 0 is connected to Y0, LED 1 is connected to Y1, LED 2 is connected to Y2, LED 3 is connected to Y3. I also have LEDs connected here. It's for the select lines. So on the 151 IC chip, the select lines, which are pins 9, 10, and 11, are connected here, with pin 4 being connected to pin 9, which is S2. LED 4 being connected to pin 9, which is S2. LED 5 being connected to S1, which is pin 10. And LED 6 being connected to S0, which is pin 11. They're here connected to the 151 IC chip. And the output of the demultiplexer are connected to pins 0 through 3. Let's see if I have everything. Before I miss something, I'm just going through and checking my pins. And for the most part, that is how my circuit is connected. The inverse of my multiplexer is going into one of the enables for the demultiplexer. All the enables, the other enables, are connected to either the VCC or the ground so that they can actually enable the circuit. Each chip has a VCC in and a ground, which is also connected so that the chips do work. The inputs of the multiplexer are coming from switches 0 through 3, and the outputs of the demultiplexer are going through 0 through 3, LED 0 through 3, and the outputs of the select lines, which are coming from the ground and from the flip-flops, are in LEDs 4, 5, and 6. With the counter, the 2-bit counter, being made by a mod 4 JK mod 4 counter from a JK flip-flop. And that is how my circuit is connected. If there's any other details I miss, I will continue trying to explain them as the lab goes on. But I'm going to begin. Sorry, this is my sister's iPad. And I'll look away so that I don't reveal what her code is. So, did all the directions here. I'm going to turn on my circuit. And a lot of wires. I've already set... Well, now I'm going to do it again. So I've cleared all my switches. It says here to set the switches S1 through S4 to 0, 1, 1, 0. 0, 1, 1, 0. Cool. This is my clock switch. Okay. No, come on. Clock the counter monitor to see to the LED. So this looks very much so like the pre-lab we had. Just give me one moment. I'll be right back. I just need to grab the pen. All right, so pen acquired. Beginning here again with the experiment. Going to part K, which is completing table 10-1. So basically, as I go through the clocking the counter, and I go through 0 to 3, and observe the outputs of each one, 74 LS 151, and the other outputs. So let me go through it. So that's 0, 1. 0, 0 gave me a 0. Ooh, wait, hold on. My bad. Let me reclock everything real quick. Cool. I'm going to redo this. I'm going to erase. So at 0, 0, 0, 0, all 4 LEDs are lit. These are active low LEDs. Outputs for the demultiplexer. This means that the output for Z, the inverse output for this one was actually 1, because the input was 0 from the 0, 1, 1, 0 data inputs. So when I'm at 0, it selected the 0 from the first one. the output for 0, 0 is 1, 1, 1, 1. Now, I'm going to clock through. Now it's going to go to the second. The second input was 1. So the inverse is going to be 0. 0. And what I observe is I have 1, 0, 1, 1. 1, 0, 1, 1. 1, 0, 1, 1. Which shows that since it selected the second one, and the second one was actually high in my data switches, it's going to come out as low because these are active low outputs. So when it's supposed to show something, it's going to turn off instead of turn on. They're all going to stay on. Now, 1, 0, which is 2. 2. 2 is also high. My fault, that's 2. 2 is also high. So the output is going to come out low because these normally are on. So when it wants to show that it's pushing through, it's going to turn off. So my output here is going to be 0. And I have 1, 1, 0, 1. Cool. Now for 3, which is this 1, 1. They're all on again. Meaning the inverse output is 1 because that third input, or D0, D1, D2, D3, D3 is a 0. So it's going to give me an inverse output of 1. And my outputs are 1, 1, 1, and 1. And that is what I get. Now, let me turn this away. What is the function of the select lines of the 74151 IC? Put your thoughts from the pre-lab 10 to the outcome of this experiment. So, the function of the select line is basically to select which data is going to be output. In the case of this experiment, we had 4 data inputs, which are switches 0 through 3 or switch 1 through 4 on the experiment, which are connected to the 74151. To select which one of these inputs is going to go to the output, as should be in a multiplexer, this is where the select lines come in. As the select lines start going from 0 to 1 to 2, or however high you put the counter to go to, however many selects you use, is going to determine which number is chosen. In the case of this 74151 IC that we used here, we only used 2 selects, with the third select the MSB being connected to 0, so that the highest we would get as a number would be 2. I mean, my bad, not 2. 1, 1, which is 3. And it would count from 0 to 3. That way, when it had to choose between inputs I0 to I3, it can choose based on whatever the select was on. And that's the function of those select lines. Explain why the select lines of the multiplexer are connected to the data inputs of the demultiplexer. Compare thoughts from pre-lab number 10. So, these select lines are connected to the demultiplexer here. They're connected to the same thing because a demultiplexer works by taking an input and choosing where it's going to go on the output. Instead of taking multiple inputs and choosing which one of the multiple inputs it's going to go to, it's going to present, it takes one input and shows based on the inputs which one of the multiple outputs it's going to go to. So that the way we did this is that we connected both the selects and the data inputs to the same flip-flop. That way they were counting at the same time. They were counting 1, 2, 0, 1, 2, 3, 0, 1, 2, 3. Since it's the data inputs, the counter's also going to count up 0, 1, 2, 3. It's not necessarily counting exactly the same as the 74151 IC chip, but here's where the inverse output comes into play. Since it's the inverse output and it's connected to an active low enable, anytime the output for the multiplexer is 1, the inverse will be 0, and this chip will be enabled, which will allow for that to be going to show through. For example, if I click once, it's going to select data input I1, which is high. As you can see here, I0, I1, I2, I3. Switch 1 is I1. It's high. I have chosen 1. As you can see here, this is my select lines. 0, it's here. 1, 2, and 3. So 1 is selected, and it's high. And you can see that as that 1 is pushing through, it's going to enable the actual demultiplexer, because it's going to send a 0 through the inverse. And the multiplexer, since it's counting and it knows that the flip-flop is on 1, as we can see here, it's going to show a 1. It's going to send data to 1. As I go to 2, switch 2, which is I2, is also high. And you can see here that our flip-flop is counting on 2. Our counter is on 2. And it's going to push it through so that as the flip-flop pushes 2, as the counter pushes 2 to the demultiplexer, and it shows that this high output has given an inverse low, is going to allow this 74138 chip to actually work. If I flip this one more time, they all come high because the output of the third 3 is low. And low is going to give me an inverse high, and it's going to disable the chip. And that is how the select lines, that is why the select lines are also connected together. What is the function of the mod 4 counter? Function of this mod 4 counter is to act as a 2-bit counter. With a 2-bit, you have a 0 and a 1. The highest you can count is 1, 1, which is 3. But that's mod 4 because it's 4 states. It's 0, 1, 2, 3, and that's it. 4 states. When we do that, since we have switches 0 through 3, or data inputs 0 through 3, as we go through 0, 1, 2, and 3, it's going to select the data for each of those switches and push it through, allowing for the multiplexer to push through the value and the demultiplexer to actually show the value. That is the function of the mod 4. Let's see if there's something else. So sorry, this turns off after like 2 seconds. And that is it. That is my entirety of this circuit and this lab.